Subgraph, which is a collection of indexed blockchain data, can be used to index a particular kind of blockchain data. For example, if you want to index all the NFT transfers, all the events of a particular smart contract, NFTs held by ENS domains or tokens held by ENS domains, and the list goes on and on of subgraph use cases. So hi everyone, this is Sahil from QuickNode, and today in this video, we will see that how we can create our own custom subgraph and then deploy it on a hosted network. So without any ado, let's jump into it. So the first step would be to install the Graph CLI globally. And hence to do that, I'll do sudo npm install -g add graph protocol /graph CLI. And -g is the flag for global. So I'll just install it. All right, so once it's installed, let's initialize a new graph project by doing graph init --studio. So what this will do is this will initialize a new Graph Studio project, and then the name of the project will be link contract. And why we are naming it as link contract is because we will be indexing the link token smart contract on the Polygon Mumbai testnet, which will be this smart contract. So what we will do is we will index all the events and all the information of this smart contract in our subgraph. And let's go back, hit enter, select the network as Ethereum, subgraph slug as same, directory as the same name, and then let's select the network as Mumbai. And in the contract address, let's paste our contract address. It's fetching the ABI of the smart contract, and this is the start block, which is the block at which the contract was deployed. So hit enter. The name of the contract is, let's name it same as our subgraph, link contract. And it's asking us that if we want to index events or not. So yes, we want to index events. And now it's asking that if we want to index another contract or add another contract to the subgraph or not. So a lot of times, one smart contract's data might be interlinked to another smart contract. For example, ENS contracts registry data gets data from ENS contracts resolvers. So those are interlinked. So in those cases, you might need two different smart contracts or more than one smart contract. So in our case, we just need one contract. So I'll just do N, and that's it. Our new subgraph directory is created. Let's enter the directory and open it in the code editor. So this is how our directory looks like in the code editor, and this is the main file. So as you can see, the name is link contract, network is Mumbai, this is the smart contract address, the ABI name, start block, mapping, and these are the events, and this is the ABI which it fetched from smart contract using the Etherscan API. And now what we need to do is go to the Graph Studio, where we will need to connect our wallet and create a new subgraph in here, because we will get a deployer ID using which we can deploy our subgraph. So as you can see, we have a deployer ID over here. So let's copy this, go back to our terminal and authenticate our command line studio using the deployer ID. So as you can see, the deployer ID is set. Now we can deploy using this ID, deploy the subgraph using this ID. And after this step, what we will have to do is install the subgraph add-on, the Z subgraph add-on from the QuickNode Marketplace. So since we are deploying our subgraph on Polygon Mumbai testnet, we will go to a Polygon testnet endpoint, go to the add-ons tab, look for the subgraph add-on, the hosted subgraph add-on, and then install it. Over here, you'll find all the information around plans, which endpoints will be compatible with this add-on, and all the other informations around rate limiting, API units consumed, etc., etc. So let's install it. Once it's installed, you'll find it under the installed add-ons, and from there, click on the ellipsis menu, then click on dashboard. It will take you to the Zeev dashboard by performing SSO, which will look like this. And over here, we'll have to create a new subgraph. Let's give it the same name, what we chose in the CLI. And if you have more than one workspaces, you can choose between them. But over here, it's the default one. And then in blockchain network, choose custom. And in RPC endpoint, we will have to get the HTTPS RPC endpoint, which is this, and then paste it over here. And then add the subgraph. So now our subgraph on Zeev is created, and we will have to link this with the subgraph we created in CLI, and then the subgraph which we created on CLI or locally, it will be deployed on the Zeev hosted network. And we will need these deployment commands. So this network name, we will have to copy this network name, go back to our subgraph.yaml file, and on this line where it says network, we'll have to replace the network field with the name which is there in the Zeev dashboard. And then we'll also have to change the version, the spec version, from 1.0.0 to 0.0.8. And that will be it. Now let's go back to our terminal and create a script for deploying our subgraph and build the subgraph. So for that, we'll do graph code gen and graph build. So as you can see, once it's compiled and built, you will see a new directory created under generated and a new script created under that directory. This will help us to deploy our subgraph. And once this is done, go back to your Zeev dashboard, copy this command and go back to your terminal and paste it, then hit enter. This command will be used to deploy your subgraph. And the version, let's name it 0.0.1 version, but you can name it anything. Once all done, you'll see output something like this. And on the Zeev dashboard, this label which says not deployed, once you refresh it, it should update and say deployed. And after some time, it will start syncing. So what it will do is it will sync the data from this block to the latest block on the Polygon Mumbai testnet. So once it starts syncing, you can track the status over here by tracking the percentage completed or the percentage synced. So it will sync the block where the smart contract was deployed until the latest block. The earlier or the older the deployment of the contract is, the more time it will take, because those number of blocks which needs to be synced increases. But since this subgraph is powered by QuickNode, it should be pretty quick. So since it's syncing and it has started syncing, we can start querying our subgraph until the blocks it has already synced. So to start querying or to query our subgraph, let's just open it in a playground or a GraphQL playground. Click on explore, then let's track transfers, and then let's track the first 10 transfers since the contract was created, and then print these block data. Actually, let's just track 5 so it's easier to view on the screen. So once you click on this button, you'll get the first 5 transfer transactions since the contract was created, and you'll get all of these information which you have set. And yeah, it will take some time for this to sync, but you can still start querying it. And if you want to query in your code, you can use this endpoint, this subgraph endpoint. So this is how you can create and deploy your own subgraph on a hosted network using hosted subgraphs add-on from the QuickNode Marketplace. So if you learned anything from this video, make sure to give it a thumbs up, subscribe to the QuickNode YouTube channel, and I'll see you in the next one. Bye-bye.